Hello everyone, welcome to Learn DAX channel. My name is Siddesh and this is part 3 of the end-to-end project video series in which we are considering a bunch of business problems and then converting them into DAX queries. If you haven't watched the first two parts, I would really encourage you to go ahead and watch them as we are building in each video. So the problems that we are going to consider in this video are as follows. So the first problem that we are going to solve is to calculate the moving average of sales that have occurred over the last 3 days. So what do I mean by that? So let's go to Excel and just try and understand simply what do we mean by a 3-day moving average. So I have, let's say, this particular Excel sheet in which I have the days on which the sales have occurred and the sales that have occurred on those respective dates. So if I take a look on the 1st of July, rupees 100, on the 2nd of July, rupees 150, on the 3rd of July, rupees 200. So 3-day rolling average means that the sales that have happened over the 3 days, if I average it, the value that I get is my rolling average. Similarly, from the 2nd of July to the 4th of July, the sales that have occurred, if I take an average of those 3 days, the value that I get is the rolling average for those 3 days. Similarly, from the 3rd to 5th, the value that I get, the average that I get for the sales that have happened in those 3 days, that's the rolling average for those 3 days. So if I go back to Power BI and if I take a look at my orders table, so I would see that, let me just clear this filter. So I would see that there are certain orders that have been placed on these order dates like 1st of July, 2nd of July, 3rd of July, 4th of July, etc. So let me first just clear this sorting. Hmm, and maybe I'll just sort it by order ID. Yeah, I'll sort this by order ID instead of, or what if I clear the sort. So now the table is in its original form. And I've quickly taken some time to create a sales amount table so that we have a sales amount table in our table itself instead of trying to calculate it always on the fly. That can help us improve the performance. So I've simply created a new column, and in that new column I've just mentioned like, okay, sales amount new, I will call it, will be the product of quantity from my orders table multiplied by the price from the products table. So this is exactly what I've done in trying to create the sales amount column. If you need a refresher on the concept of related and related table, I've created a video on that. I will leave the link in the description. You can go check that out. So right now this is the orders table along with an extra sales amount column that I've already created, which we are going to use while creating the 3-day moving average. So let's get back to our report view and let's start building the query for our 3-day moving average. So let me call it moving average 3 days. That will be, I will need an average x function first of all, because there is a table upon which I am going to calculate the average and there's going to be an expression. So I'm going to calculate the average of the sales amount that is happening over a period of 3 days. So in order to get those 3 days, I'm going to use a filter function. So let me write a filter and I will use the orders table. Obviously, the orders are coming from the orders table. So the orders table. Now I want to filter out, let's say today is 1st of July. So in order to get 3 dates, which is 29th of June, the 30th of June, and 1st of July, I'm going to use a condition that's going to encompass all the 3 dates. And how do I do that? I'll just write it and then I'll explain it. So my orders date should be greater than or equal to max of order date, which in case of 1st of July is going to be 1st of July. So if I'm in row 1 where the order date is 1st of July, in the same context my max order date is going to be 1st of July. When I write -2, it means it goes back by 2 days. So it goes back to 29th of June and compares 1st of July with 29th of June, and it returns true because 1st of July is greater than 29th of June. And similarly, 1st of July is greater than 30th of June. And also, 1st of July is equal to 1st of July. So that satisfies, these three conditions are satisfied with this condition. And order state should be less than or equal to max of order. We are kind of putting at a stop, like, okay, stop at this point. Once you have reached the point where you have iterated 3 days backwards, you need to stop at the date where this order date is less than equal to max order date. So let's say I am on the 2nd of July. The first condition is helping me go backwards and come to the point where I am. And this condition is sort of putting a stop on how further I should go. So with that taken care, I now have 3 dates being filtered every time I'm using this filter condition. And in order to simplify this, I have created a small table in Excel. So let's get to that table and try and understand what I all said right now. So if I go to my Excel sheet, and if you take a look at this particular table, so in the first iteration, the order date is going to be 1st of July. And the max order date in that context is also going to be 1st of July. Now, the order date minus 2 days will return me 29th of June and 30th of June, but it is greater than or equal to, which means it is also going to include the 1st of July. So the greater than condition fulfills 29th of June and 30th of June, and the equal to condition from the greater than or equal to fulfills the 1st of July. And if I apply the same logic to the second iteration, which is the 2nd of July. Again, the order date will be 2nd of July. The max order date in that context will be 2nd of July. The condition where the order date should be greater than or equal to max order date minus 2 satisfies the condition such that the greater than condition is going to give me the 1st July and 2nd July, and the equal to condition is going to give me the 2nd of July. So the dates that are getting filtered are 30th of June, 1st of July, and 2nd of July. And you can see this mentioned here that what are the filter dates, what are the filter dates. And I will provide this table or this Excel so that while you are practicing and while you are going through this particular query, that you can take a look at what iterations are working and how the values are getting filtered. So now let's get back to the formula and see how we are building up to that solution. Now that we have filtered our values, the next step is to what do I want to average? There has to be something that I need to calculate an average for, and that is my sales amount. And which is why I already calculated the sales amount in my orders table so that it doesn't have to calculate it on the fly. I will already have that in my table. So that will just reduce the load and improve the performance. So now that I've calculated the moving average, I will quickly pull the order date and I will consider this as the order date. Then I will pull out the moving average. Now there is one thing which is wrong right away, which is I'm seeing a moving average for the 1st of July, even though there have been no sales on 29th of June and the 30th of June. I'm seeing a moving average for the 2nd of July, even though there was no sale on 30th of June. So while seeing a moving average for the 3rd of July, I should see a moving average that is from the 3rd of July. But since I'm seeing the values for the first 2 dates, it means there's something wrong in the formula. And let's fix that thing first. Before even concluding if the remaining values are true, I know that I shouldn't see these two values because if I go back to my Excel and if I take a look at this sheet, for the 1st and 2nd of July, there is no rolling average because if I go back by 3 days, there are no sales. So I only need to start calculating the rolling average when 3 days have passed or 3 days of orders have already been processed. So I go back to Power BI and I will use an if condition, a simply if condition, such that if this filter condition is returning me 3 rows, which means 3 dates. Only then do the calculation, otherwise don't do the calculation. So I will write if count rows. So count rows function will count the rows of a table. So I'll copy and paste. If this equals 3, then calculate the average, otherwise don't. And then I'm going to give the alternate condition, which is should the result be false, give me a blank. I don't want to see any output. Now let's see what happens. Well, we don't get to see anything. This is absolutely strange. Let me try and fix this. There's one thing that we haven't done in this formula, and that is we haven't negated the inherent filter context. So we need to wrap this orders inside an all function so as to negate the inherent default filter context being introduced by the orders table. So once I do that, I should get the correct output. Or do I? Well, let's find out. So while I am getting the moving average from 22nd of July, I don't see the values from 1st of July to 21st of July. And why could that be? Let's do some digging. So right now, I am seeing a value from 22nd to 31st of July. So let's go to the orders table and try and understand what's so peculiar about these dates that, hey, it just wants to calculate from the 22nd of July. Why is it being biased towards those dates and not being unbiased in its result? So let's try and filter the dates in the vicinity of my output, which is I see a dates from 21st July, so 21st, 22nd, 23rd, 24th, 25th. And let's go back few days 20th, 19th, 18th, 17th, 16th, 15th. And let me sort this in ascending order. So it has given me the output from what was the date? Let's go back 22nd of July. So I see there is one pattern here, which is from the 21st of July onwards, there has been only one order on each day. So 21st, 22nd, 23rd, 24th, and 25th all have had only one order in each day. Whereas if I look at 15th, two orders, 16th, two orders, 17th, two orders, which means that in my moving average, this condition, which is count rows, filter, if the number of rows is 3, only then calculate the moving average. That is not returning me true for the dates before the 21st of July, because for each day, if there are more than one sale that have happened, it is going to calculate more than 3 values. Because let's say I am on the 3rd of July, if the 1st of July is coming twice, 2nd July is coming twice, then obviously the filter condition is still going to return me true, given that the 1st of July is going to be less than 3rd of July minus 2, and that the 2nd of July is going to be less than 3rd of July. But since the number of rows that it will return is going to be more than 3, I'm not going to get the correct output. And so, in order to work around this, what we're going to do is we will create a new table in which for each day we will have an aggregated sales amount. And which function are we going to use for that? I think you can guess it because we have used that function so many times that that has probably become our second nature. So we are going to use the summarize function. So what we are going to do is we will create a new table so that for each order date we are going to aggregate the sales and then try and calculate the moving average. So I will call it sales per day is equal to summarize, and we are going to summarize the orders table because we have to calculate the orders on each date. So order date, group by the order date, and the total sales amount. I will create a new table or a new column. Total sales amount will be sum of the sales amount from the orders table. So for each date, it will aggregate the sales that have happened. I hit enter. So in this case, what I should be getting is for each day, what were the sales that have happened in an aggregated form. Let me just change the formatting a little bit so that it's a short date. So now what I see here is that for the 1st of July, the aggregated sales were 20,800. For the 2nd of July, the aggregated sales were 3,175. For the 3rd of July, the aggregated sales were 5,400. So let's just make a quick check if our values are correct. Let's go to our orders table, or we can do one thing. We can pull orders date from the order table and change it to an order date instead of a hierarchy. And we have created this sales amount measure in our previous video. If I pull it here, I get the aggregated amount. So if I compare it side by side, I have 20,800 for the 1st of July, 20,800 for the 1st of July, 3175 on the 2nd of July, 3175 on the 2nd of July, 5400 for the 3rd of July, 5400 for the 3rd of July. So we have verified that part. Now let's go about modifying this measure in order to create the moving average 3 days using the sales per day table. So instead of orders, I will write sales per day. And instead of orders date, I will have sales per date. And we will just copy and paste this throughout, because we are replacing everything with sales per day order date. And now instead of making changes there, I will just simply copy here and paste it here. And instead of order sales amount, we will have sales per day total sales amount. Now if I go back and try and calculate the same thing, what do I get? Well, this is coming from an orders table. Let me pull it here. So this is probably because the context in which it's being called is different. See, now you can see the difference. I have the order date here. I have the order date here and I have the order date here, but the moving average 3 days is giving me a different output in this case and giving me the correct output in this case. And this is because the order date in this visual is coming from my orders table, and it has no connection with the order date that I have pulled in this table from my sales per day table, which is why we are getting a different output. So we are not going to pull the 3-day average with the order date from the orders table, but the order day from the sales per day table. So I quickly delete this, and now let's do our checking. Let's verify if our output is correct. So for the 1st of July, the sale was 20,800. For the 2nd of July, it was 3175. For the 3rd July, it was 5400. Divided by 3 gives us 9761.67. So that's correct. Let's try for the 2nd, 3rd, 4th July. 5400 plus 1155 divided by 3 gives us 3243.33. So that's correct. Let's just do one more check and then we move on to the next question. 5400 plus 1155 plus 5000 divided by 3 gives us 3851.67. So we have verified that. So we are done with the first part, which was probably the most challenging part. Now we do the easier lot of the questions. So calculate the sales contribution of each supplier to the total sales. This is going to be fairly straightforward. So I have my suppliers table. Let me clear this filter first. Clear all filters, clear sort. So what was the question again? Calculate the sales contribution of each supplier to the total sales. So first of all, I would need to calculate the total sales for each supplier, then calculate the total sales neglecting the filter context of each supplier, and then divide the sales of each supplier to the total sales. So let's try and calculate that. What are we going to do? Summarize. So contribution by supplier will be summarize suppliers. Yeah, we will need the supplier ID, supplier name, and first thing we need is the sales per supplier will be sum x orders. I think we can keep it simple and simply use the order sales amount. We don't need to do any multiplication in this case. Total sales will be sum x. Well, this is tricky. Orders price, orders quantity into related products price. But since I want to negate the effect of the inherent filter context, let me wrap this around an all function. And then the next thing I need is a divide function, because I want to divide contribution by supplier will be, so I will use a divide function. Can I simply use the column name sales per supplier? No, I cannot. So I will have to divide this quantity by this quantity. And I think I need one more bracket here. If I get a 0 by 0 condition, give me 0. I multiply it by 100 so that it gives me a value in percentage. I think that is pretty much it. This is for sum x, this is for sum x, this is for divide, and this is for summarize. So if I quickly now pull, so I need the supplier name, I need the sales per supplier, and I need the total sales and the contribution per supplier. So if I want to do a basic check if the measure that I've written is correct or the query that I've written is correct or not, I will simply pull the supplier name from the suppliers table. Where do I have it? The supplier name. And I will pull the sales amount from the sales amount measure. And I will also need a total sales amount, which I will just create, which will negate the effect of the inherent filter context. So call it total sales amount, will be sum x, all orders quantity multiplied by related products price. And if I bring it here, so yeah, we have verified this. We don't need another column which will do the divide, because 4530, 4530, 6540, 6540, 1230, 1230. So I verified that part. Now let's move along to the third question, which is calculate the average delivery time for each supplier. So for this, I am going to create a new calculated column in my, which one? Shipments? Yeah, shipments table. So let's just check. Okay, I already have the delivery days. Oh, yeah, so in my provided data set, I already have the delivery days. So I don't need to calculate a new column which will give me the delivery days. So all I need to do is just go to re report view and create average delivery days will be average. You can simply use average delivery days. And once I pull this measure in context of the supplier, it will give me the average delivery days for each supplier. So let me pull in a new page. Let me pull in my supplier name quickly. And where was it? Average delivery days. So the average delivery days for the active supplies, supplier name is 3.2. For Apex Sports Supply, it is 3.63. Let's do a check if this is correct. So I will pull the supplier name, and what else do I need? I need the shipments table, the actual delivery days, not the date, the delivery days. And now instead of using the aggregation as a sum, if I use an average, yeah. If I do that, I see 3.2 for active supplies, I see 3.2 for active supplies. I see for Apex Sports Supply it is 3.63. I verified that. For Aquatic Essentials is 4.33. Again, 4.33. So we are done with the three questions for this video. So this brings us to the end of this video. I hope you enjoyed watching this video. If you did, please share it with your friends, and I will provide the Excel sheet so you can take a look later when you are practicing this particular questions. If you have any feedback, please let me know in the comments. And yeah, like I say at the end of every video, thanks for watching and happy learning.